NCBM 0324, Section 1.4, Evaluating Functions Using Function Notation, Part 4. Let's see another one of those x plus h problems. I mentioned how important they are for your other class. So looking at this one now, we have f of x is equal to x squared minus 3x plus 9. So already thinking about skeleton, we have x in two places. We're going to have to make a space for the x squared and the negative 3x. So that's our first step, building our skeleton just so we have it on hand. So f of whatever's on the inside of that notation of function notation, we're going to have to square it, subtract 3 times that value plus the 9. Okay, so the first one, now maybe these are a little bit more manageable. We're going to plug in for this first one, we want to find f of 3. So we want to know the function value at 3. So here's my skeleton. I'm going to plug in 3 into those empty spots. And then I start my order of operations. So 3 squared is 9 minus, I'll go ahead and do this, 3 times 3 is also 9 plus 9. And when we combine these, I know 9 minus 9 is 0, so that's pretty nice. So that cancels away to 0 plus 9 leaves that last 9 there. So f of 3 is equal to 9 for this function over here. The next one is an f of t. So t is at substitution. T is going to go into these blank spots. So let me draw my skeleton for this particular function. That's squared minus 3 times the parentheses plus 9. So f of t is simply going to equal to t squared minus 3 times t plus 9. I made a little jump there. If you need to see the plugging in step, perfectly fine. And we plug it in here, plug it in there, and we get that as our result. Basically, we switched variables from x to t. Next one, we have f of x plus 2. All right, same starting point. Same place to begin. Let's draw our skeleton. So the squared minus 3 times another parentheses plus 9 is my skeleton. So like we said, whatever's on the inside, doesn't matter how intense it may be, what's involved, because it's inside the parentheses, that's what I'm going to plug in to these blank spaces I've saved. So that x plus 2 goes in both spots. Now to evaluate this one's going to take a little bit of work, because when I see something like x plus 2 squared, this is a binomial because it has 2 parts to it. When I have a binomial raised to a power, it's tempting. It's so very tempting to just distribute the power. But that's not allowed because of the addition. Because we have, or if it was subtraction as well, that still wouldn't be allowed. My exponential rules don't distribute over addition or subtraction. So in other words, how am I going to evaluate this? Well, what does it mean to square something? It means I multiply it by itself. So I'm going to have x plus 2 times x plus 2. And when I write it out like this, I might be reminded of that thing we've seen a lot in our classes. We're going to have to FOIL this out. We're going to have to use that distributive property. In this case, FOIL is our acronym to remember the parts. But we're going to use that property to get our full answer here. Okay. And then over here on the 3 times the x plus 2, that's just a single term. So I can multiply that one in. I'm going to go ahead and do that now. So I'm going to have minus 3x minus 6 plus 9. All right, so let's do the FOIL then. let's see what this all multiplies out to be. So FOIL, we use that acronym because we're going to remember the parts we need to multiply. So FOIL, first, I'm going to multiply x times x, and that gives me x squared. Then I'll do the outside, x times the 2, well, that's going to give me a plus 2x. Then the inside, 2 times x, that's another plus 2x. And then the last parts, 2 times 2 gives me a positive 4. So you can see the distribution happening. We distribute the first term all the way through, the second term all the way through. And the FOIL helps us remember how that's done. I still have the minus 3x minus 6 plus 9. And in this case, there is a lot we can combine. I want to simplify it as much as possible. So let's see, x squared, there's no other x squares in here, so that's just going to be a single x squared. I do have a lot of x terms, right? Things that have x to them, but no power, just x to the first, really. So I'm going to look at 2x plus 2x, well, that's 4x, minus 3x, well, that's just going to give me a plus x, right? Or 1x if you want to see the 1 in front, that's okay. Then looking at our constants, we have 4 minus 6, well, that's negative 2. Negative 2 plus 9 is a positive 7. And there it is, our new function built from evaluating at x plus 2 into our original function from the beginning over here, right? So we're building new things. We don't know new variables, but we're knowing how it's going to be affected if we do this substitution in there. All right, last one. Now we're going to go back to that f of x plus h. F of x plus h. So we're plugging in x plus h. Well, very similar to the last one, I'm going to make my parentheses a little bit wider in my skeleton because I know I'm going to have an addition in here to plug in. So there's my skeleton. Whatever's inside that parentheses is going to go into these parentheses. So I'm going to square it, minus 3 times that value, plus 9. And what is that value? It's the x plus h. Again, very tempting to simply say x squared plus h squared, but technically, mathematically, that is incorrect. Right? We would be missing a lot of the extra bits that the distributive property in FOIL ends up giving us. So to remind ourselves of that, let's write out what it means to be squared. Well, you multiply it by itself. So x plus h times x plus h. I'm going to go ahead and distribute that negative 3 again, just to get that going. So I'm going to have minus 3x minus 3h plus 9. Then we'll do our FOIL, distributive property, first term, x plus h, there we go. So first term, x times x is x squared. Outside terms, right? Yeah, the O in FOIL is outside term. So x times h, we're going to say plus xh. Then the inside, x times h again, right, or hx. Well, I can write that as hx there. The same variables are being multiplied. And then the last terms, h times h gives me h squared. I still have all of these other ones, this minus 3x minus 3h plus 9. And let's see what we can combine. We were able to combine quite a bit in the last one. Let's see what happens here. X squared, ooh, that's the only x value that's squared. I can't combine it with the h squared because that's a different variable. So I'm going to have x squared plus I have an XH, I have another XH. So these have the exact same variable. So those are I am able to combine here. So I have XH plus XH. Well, that's two of them since they're being added. Let's see, the H squared, that looks to be the only H value squared, so we'll keep it down. Minus 3x. Can I combine it with the XH's? Should I have done it over here? Not quite, because it doesn't have an H, right? So it's still different than our other ones. And the same thing with the minus 3h, right? It only has an H. It doesn't have the X that these other ones had. And then the 9 is my constant. There's no variable to it. It's just getting added at the end. So in this case, our answer looks pretty impressive. It's really expanded out and showing a lot of the pieces that are coming from that x plus h substitution. And again, FOIL, the distributive property for these, it's easy to miss, so keep an eye out for that step. But otherwise, it's the same thing you would do with numbers we're doing with these x plus h's. We're simply plugging them in.